Level 2 of your function features grid is all DeltaMath questions. There are 4 topics. I have you do 3 on the first 2 topics and 2 on the last 2. We'll do a couple examples from each thing here, and then you can try some on your own. Okay, the first one, we're talking about one of the vocab terms, increasing and decreasing, and positive and negative in terms of intervals. So they give you a function, f of x, graphed below. What is true about the graph on the interval from x equals c to x equals infinity? Okay, so first of all, what does this part here mean? X equals c to x equals infinity. Here's c, it's an x coordinate right there. They don't give you any numbers, but they don't need to. X equals infinity means what happens if you just stretch out x forever and ever and ever and ever and ever in this direction. In other words, as the function goes to the right forever, that's what infinity is kind of showing here. So start at c and then go to the right forever and ever, but still be on the graph. So as the graph goes to the right, it's going down here, and the arrow tells us forever, right? So what is this function doing? Well, as I go from c to the right, it's decreasing, it's getting lower the whole time, and it's below the x-axis. So on this entire interval, it's negative and it's decreasing. It's negative and it's decreasing, right? They'll highlight it in green for you on the example, and then you can decide for yourself there. Let's try another one. Okay, from point A to point B. Here's my graph. I'm just concerned about the region from point A to point B. That's right in here. From point A to point B, it's below the x-axis, so it's negative, and it's decreasing, right? It's going down. So it's negative and it's decreasing again. You might be asking yourself, well, wait a minute, is it even possible to be negative and increasing, or is it possible to be positive and decreasing? Let's see if we can find one of those. Point A to point B, let's skip that one. Let's skip that one. Okay, there's a good one. So from x equals negative infinity to x equals a. All right, negative infinity, we're still in the x direction. Negative just means the left, right? Negative means either left for x or down for y. So go to the left forever and ever and ever and still be on the graph, right? So here's the graph. To go down left forever and ever, it goes down. So I'm starting here and I'm going up to x equals a. So start down, come up to a, right? And as we're saying it, it's going up, it's increasing, right? The y coordinates are getting higher, but on this entire interval, it's still always below the x-axis. So this entire interval here from negative infinity to a, it's negative, but it is increasing. I know there's an arrow here that says it's going down, but as you go to the right, start from the left and go up and to the right, it's increasing. So your answer would be negative and increasing. Let's see if we can find one that's positive and decreasing. That's also negative and increasing. C to infinity. That's what we just did. That's what we just did. I want to find one that is positive but decreasing. D to E. Okay, there we go. From point B to point C. Here's B, here's C. Notice that this entire region, let me show you the solution here. They'll show it in green. Here's the interval in green. It's positive the whole time. It's above the x-axis, but it's going down as you go from the left to the right, from B to C. It's going down, so it's decreasing. But it's positive because it's above the y-axis. That's the first topic. A few of those for you to do. Second one is identifying extrema. Extrema are your maximums and your minimums. Sometimes I think they'll ask for a minimum. I think sometimes they'll ask for a max. And sometimes they'll say either an extreme value or an extrema. So let's start with this one. Function is graphed below. How many points represent a minimum? A minimum is where it changes from decreasing to increasing. Point B right here. Some of you have already started this, by the way. It's easy to think, oh, the answer is 1. There's 1 point that's a minimum. Point B here is actually a maximum. It's the highest point on the graph. It's changing from increasing, then you get there, it switches to decreasing. You might say, well, down here is a minimum because it's very low. The reason this isn't a minimum is because, first of all, there's not a point there. It's just an arrow. But also, it has to change from increasing to decreasing or vice versa. There's no change here. It's just all decreasing, right, as you go from the right to the left in this case. So there are no minimums here. The answer would be 0. No relative minimums. Let's do a different one. How about relative extrema? There we go. Relative extrema, or relative extreme value, just means are there either minimums or maximums. I can see here that point A, it's decreasing until I get to A, and then it changes to increasing. Decreasing to increasing means this is a minimum. The point A is a minimum. That's 1 extreme value. Keep following that out, I get to point B. Now it's changing from increasing, and then when you get to B, it starts decreasing. So that's a maximum. There are 2 extreme values. This is a min, this is a max. Point C, what's going on there? It's decreasing when I get to C, but after that, it's still decreasing. So this is not a maximum or an extreme value. So the answer is 2. Point A and point B are your extreme values. A is a minimum, B is a maximum. We'll do one more. Okay. How many points in this graph represent a relative minimum? Okay. I'm looking for low points, right? Once you do a few of these, you'll get the hang of it. A minimum is essentially a low point. Point A, that's a maximum. It's going from increasing to decreasing. But point B, that's a minimum. It's switching from decreasing on the left to then increasing on the right of the point. So B is a minimum, 1 so far. Point C, it's increasing on both sides of C. This is increasing, this is increasing. So that's nothing. Point D, that's a maximum, increasing to decreasing. Point E is nothing. It's decreasing and then still decreasing. But point F, that's another minimum, right? It's switching from decreasing to increasing. And then point G, that would be a maximum. It's switching from increasing on the left of the point, switching over to decreasing on the right of the point. The 2 there. Topic 3, even and odd. This is talking about symmetry from a graph, okay? When it says the degree of the function, this was not in your vocabulary notes, but this is what we talked about in December with graphing polynomials. Even degree is when it has the same beginning and end behavior. Odd degree is when it has opposite. Either starts negative, ends positive, or it starts positive and ends negative. That's degrees, okay? So since this is both starting and ending positive, it's an even degree. And then is it actually an even function? What that's saying is it completely symmetrical over the y-axis? As I look at it, the answer is yes. This point here is an x-coordinate of 1. It would flip over there. This point here at 240, that would flip over to negative 240, and so on, right? This is completely symmetrical over the y-axis if you were to imagine folding this in half. So it's an even degree and it's an even function because it's symmetrical about the y-axis. So even and even. Even degree, even function. Okay? That one's also both even, right? Symmetrical about the y-axis. Let's find a different one here. All right. This one has the same beginning and end behavior. It starts positive and it ends positive, but it's not symmetrical about the y-axis. This point here is at 1.4 or something like that. If you were to flip that across the y-axis, it'd go right about there, but there's no point to match up with it. So that's an even degree, but it is not an even function. What that means is what even function means is, does it have symmetry about the y-axis? Even degree is just talking about the beginning and end behavior. Let's see if we can find an odd one. This is an odd function because it starts negative and ends positive, so it's odd. The question is, does it have symmetry? Is it able to be rotated 180 degrees or turned upside down and still look exactly the same? The answer here is no, because there should always be a point in the middle at the origin. That's where you're rotating your graph. But if you were to imagine turning your screen upside down, so I can zoom out here. If you were to rotate upside down, this point right here would end up being down here, which means it's not symmetrical. I want it to go right on top of itself. So it's an odd degree, but it's not an odd function. Let me find one that is an odd function with rotational symmetry. That one's not. That's an even function, or an even degree. This one here, okay, it's odd because it starts positive, ends negative, so it's opposite behavior. And if you were to rotate this upside down, this point would exactly line up there if you would rotate it. Think about the coordinates here. They're about 2.5 comma 35 maybe, 2.5 comma 35. Down here, it's the same coordinates, but just they're both negative now. Negative 2.5, negative 30 point, or negative 35, something like that. So this one is an odd function. Degree is talking about end behavior. Are they opposite directions or the same direction? And even or odd function is talking about symmetry. Can you rotate it? That's an odd function. And can you flip it reflectionally across the y-axis? That's an even function. Okay, last topic is end behavior graphically. You have done this exact topic before. I'll do a couple here to get you refreshed. So this is an even degree because it's starting and ending the same way. And there's a lot of symbols used here to describe the beginning and end behavior. All this is saying is, as the graph goes to the left, it's going down. And as the graph goes to the right, it's going down. So in other words, the y-coordinates are both going to negative infinity both times. So which choice says that the y-coordinates always go to negative infinity? This one says y goes to negative infinity, but that one says y goes to positive infinity. So it's not that. It'd be this choice right here. As x goes to the right, positive infinity, the function goes down, negative infinity. And as x goes to the left, negative infinity, y again goes down, negative infinity. We've talked about this before in December, so hopefully it's a review. Let's do another one as an example here. Okay, this is an odd degree because it has opposite behavior. Question is, how do we express it? The last question used y's. Looks like this one is using f of x's. So as x goes to positive infinity, positive in the x direction means towards the right. So as we trace out the graph to the right, it's going down. So I want x to go to positive infinity and f of x to go to negative infinity. So it's either choice 2 or choice 3. As it goes to the right, it goes down to negative infinity. So as x goes to the left, towards negative infinity, you might think, wait a minute, it's going up. And yes, that's the whole point. The graph, the x coordinates are going to the left, negative infinity, but the y values are going up to positive infinity. So I want the one where it says right is going down, and as I go to the left, x negative infinity, the function goes up to positive infinity. Okay, so that's the DeltaMath level 2 problems for you there. On your grid, you can check these off one by one on the grid if you want, or you can just check them off all 4. Once you've gotten the credit, you can go ahead and mark it green. You don't have to wait for me to do that. I will do it if you don't, but that's level 2 for your grid, all DeltaMath questions.